Hello class 10. Let's solve the exercise 6.3 of your Ncert book. In the first question, it is given, state which pair of triangles in the given figures are similar. Write the similar criterion used by you for answering the question and also write the pair of similar triangles in the symbolic form. In the first pair of figures, we can see in triangle ABC and PQR, angle A is equals to 60 degree and angle P is equals to 60 degree. So I'll write the same right here. In triangle ABC and PQR, angle A is equals to P because each of them are 60 degree. Then angle B is equal to angle Q, that is equal to 80 degree, and angle C is equal to angle R, that is equals to 40 degree. So we can clearly see that the corresponding angles for all three of them are equal. Since all the three angles are equal, therefore we can say that by AAA similarity criterion, these two triangles are similar to each other. The second part says that we have to write the name of the pair of similar triangles in the symbolic form. This is very important. The name of the triangles can be written in any form. Say for triangle ABC, we can call it as ABC, triangle BAC or triangle CAB. We can give it any name. But when we will write down the similarity relationship, in such cases, we have to be very particular with the name. So for the first triangle, we can write down any name we suppose from the three vertex. Say for this case, we have written triangle ABC. But with respect to this order, we have to write down the name of the next triangle. We cannot just simply write down the name of the second triangle as QPR or RPQ or any other thing. We have written here as PQR due to some particular reason. Let's go through it. Here, the first angle that has been provided is A for triangle ABC. Now, from the given conditions, we can see angle A is equal to angle P. So, while writing the name of the triangles, we will write down angle P with respect to angle A. So, in the first position, we have angle A. So, here also in the first position, we have to write angle P. In the second position, we have B. So, by condition, we have got angle B is equal to Q. Therefore, instead of angle B, we will write here in the second position Q. The third one is quite obvious, that is vertex R. So, the name will be PQR. So, for the third one, we also know angle C is equal to R. So, with respect to C, we can write R, or we can simply write R because that is the only remaining vertex of triangle PQR. So, it is very important to write down the vertex properly for the first and second position. So, with respect to this name, we will write the next one. So, had the name been BAC, then in such case, the name of this triangle should have been QPR. Triangle BAC is similar to triangle QPR. So, according to the names we are choosing for the first triangle, we have to write down the relationship for the second one. In the next two diagrams, we can see that the angles are not given, but the length of the sides of the two triangles are given. In such cases, we will first write down the name of the triangles in triangle ABC and PQR and try to find out the ratio or multiple of the sides. So we can see the length of side AB is 2 and here the length of side QR is 4. Clearly 4 is a multiple of 2. So if we find out relationships like this, then it will be easier for us to find out a relationship between the two triangles. So we can see 4 is a multiple of 2, 6 is a multiple of 3 and 5 is a multiple of 2.5. So we will try to associate these pair of sides. So the first one is BC by PR. So BC right here is 2.5 by PR is 5. So 2.5 by 5 is equals to 1 by 2. Then AB by QR. AB is equals to 2 and QR is equals to 4. So AB by QR equals to 2 by 4, that is equals to half. The third one is AC, that is equals to 3 by PQ. So AC by PQ is equals to 3 by 6, that is equals to half. So clearly we can see the value of the ratios are all equal. So we can say that all the ratio of the corresponding sides are equal, and hence we have a rule with respect to it. So we have the side similarity criterion, or the SSS similarity criterion for this purpose. So we can say by SSS similarity criterion, triangle ABC is similar to triangle QRP. Again, we have to keep a note of the name of the second triangle. Since we have written triangle ABC as the name of the first triangle, so we don't have the angles given over here. So in such cases, what we can do is we will take the name of the triangle and the sides. So the first side here for triangle ABC is AB. So with respect to AB, AB here is corresponding to QR. So instead of AB, we will write down QR. The next side is BC. So BC is corresponding to PR. So instead of BC, we will write PR. So since we have already written R, so now we will write here P. Again, let's check the third one. AC, which should be corresponding to QP. So we can see AC is corresponding to QP. So this is how we can name it. If you name it separately or differently, then you might lose marks. In the next figure, we have two triangles where again the length of the sides are given. So we will try to find out the relationship between the length. So we can clearly see here DE is equal to 4 and NP is equal to 2. So 4 is a multiple of 2. DF is 6 and LP is 3. So 6 is a multiple of 3. But LM equals to 2.7 and EF is equal to 5. But 2.7 or 5 is not a multiple of 2.7. So clearly from here we can understand that we will not get a ratio which is equal to the other two ratios. Still, let us write down. So LM by EF is equal to 2.7 by 5. So that is the ratio that we have got. Let us take the next ratio, LP by DF, that is equals to 3 by 6, and it is coming out to be half. Then MP by DE, that is equals to 2 by 4, that is equals to again half. So we can see that we have a relationship between these two corresponding sides or ratios, but the third one is not valid. The third one is not equal to the other two. So therefore we have to skip it. Now in these type of cases, we can see that the SSS criterion will not stand here. So we cannot apply the SSS similarity criterion. But since we have a relationship between two corresponding sides or ratios, we can look out for the third rule, that is SAS rule. That is two corresponding sides and the angle between them. But now in this particular question, if we take these two sides are corresponding to each other, right? This is corresponding to this and 3 is corresponding to 6. 2 is corresponding to 4, 3 is corresponding to 6. So the angle between them here is P and here is D. So P and D, if they are equal, then we can say that by SAS congruence rule, these two triangles will be congruent. But here the value of the angles are not given. So hence we cannot conclude that they are similar or not. So since by the given condition we are not getting any relationship based on the criteria, that is AAA criteria or SAS or SSS, so in this case we can write that the two triangles are not similar. In this case you can write down any name for them. Okay, there is no particular order that you have to follow while writing if they are not similar. If they are similar, then you have to be cautious about the name. Hence, they are not similar. The next pair of diagrams have angles and also the length of the sides. So, since the angle is given, let us first look at the angle. So, the angle right over here, M, is equal to angle Q of the two triangles, that is equal to 70 degrees. So, we can clearly write here angle M equals to angle Q, that is equals to 70 degree. So, in triangle MNL and triangle PQR, this is very vital to write it down. Don't skip it. Next, we have to write down the ratios. So, let's choose it. So, 2.5 and 5 can be taken, and here 5 can be associated with 10. So, 10 is a multiple of 5 and 5 is a multiple of 2.5. So, let's write it down. So, Mn by Pq is equal to 2.5 by 5, that is equal to half. And ML by QR is equal to 5 by 10, that is equal to half again. So, we can see that these two are of equal ratio. So, we can see that the sides which has been provided here and here, they are these two sides, and the angle between them are also provided, which are again equal. So, by this rule, by this condition, we can say that the side, angle and side condition is valid. Here also side, angle, side condition is valid. So, we can say by SAS congruence rule, these two triangles are congruent or similar. Sorry, these two are similar to each other. Now, again we have to come back to the naming part. So, we have chosen the name for this one as NML. So, NM is associated with PQ. Okay, so NM is associated with PQ. ML is associated with QR. So, ML, QR. And here we have the angle M is equals to Q. So, wherever we will write M, in the middle section we have written M. So, in the mid section we will write here Q. That's what we have to check. Hence, they are similar to each other. In the next pair, we can see we have triangle ABC and DEF. Here, two angles are given which are equal, that is angle A is equals to 80 degree and angle F here is 80. Very good. Next, we have AB as 2.5 and DF as 5. So, 5 is a multiple of 2.5. Next, BC equals to 3 and EF is equal to 6. Again, 6 is a multiple of 3. So, let's write it down. So, AB by DF is equals to 2.5 by 5, that is equals to half. BC by EF is equals to 3 by 6 equals to half. So, clearly we can see both of them are of equal ratio. Let's check whether the angle between them are equal or not. So, we are talking about AB and DF here, and for this triangle BC and EF. So, AB and BC, this should be the angle that should be equal to this angle, right? But these are the two sides which are in proportion, not this side. These are the two sides which are in proportion with the other triangle, and this should be the angle should be equal to the other side or triangle. But here we can see that these two are given and the angle between them is equal to 80. But in this triangle, this is not 80. Since the angle between these two sides are not equal, therefore, even if angle A is equals to angle F, which is 80 degree, we cannot write that these two are congruent because they do not follow the SAS similarity rule. Okay, even though we have good conditions right over here, but they do not follow the similarity criteria, neither AAA nor SSS or SAS. None of these follows. Therefore, we have to write triangle ABC is not similar to triangle DEF. Next pair of sides are triangle DEF and PQR. These two triangles are given. Here we can see that one angle is given as 70, another as 80. In the other triangle, one is given as 80 and another is 30. But just from the overview, we can see that these two angles are not equal to these two. So clearly they are not similar. But if we pay attention, we can use the angle sum property here. So the sum of the three angles of a triangle is 180. If that's the case, then what should be angle F? 180 degree minus 80 minus 70. So we are getting 180 degree minus 150. So the final answer here is angle F is equals to 30. Now angle F is 30 here and angle R is also 30. Angle Q is 80 and angle E is also 80. So we can see that there are two angles which are equal in both the triangles. So can we apply the AA corollary of the AAA similarity criterion? We have learned it in the previous video, right? Or the previous week. So here we can say that in triangle DEF and PQR, angle E is equals to Q, that is 80. Angle F is equals to R, that is 30. Reason should be written over here, or you can first calculate and then write down the reason or the statement. So whatever you do, this must be stated. Now therefore we can see two angles are equal. We do not have to prove the third angle to be equal because it is quite obvious that it will be equal. If this is 80, this is 30, this has to be 70 degree by angle sum property. So we can see we can also follow up on AAA similarity criterion. So therefore we can say by AA similarity criterion, triangle DEF is similar to PQR. Again, we have to be very careful about the name. See, angle E is equal to angle Q. Angle E is in the second position. So, in the second position, we'll write down Q. Angle F is equal to R. Angle F is in the third position. So, angle R will be in the third position. We are left with angle P. So, we'll write it over here at the beginning, not at the end. Question number 2. In the given figure, ODC is similar to OBA. When it is given that a particular triangle is similar to another triangle, then we can get a lot of information by this simple statement or condition. When two triangles are similar, then obviously all of their corresponding angles are also equal and all their corresponding sides are in equal ratio. Next, it has also been provided that angle BOC is 125. This is angle BOC 125 and angle CDO, which is right over here, it is 70 degree. We have to find out angle DOC, that is this angle right here, angle DCO, which is right over here, and angle OAB, which is right over here. Let's start. So, from the given figure, we can see that angle DOC, which is right here, plus 125 is equals to 180 degree. Since this is a straight line, right? Since this is a straight line, we can say these are linear pair of angles. So, this angle plus this angle will be equal to 180. So, angle DOC plus 125, that is equal to 180. Therefore, angle DOC can be written as 180 minus 125. This one goes to the other side and becomes negative. So, if we calculate, then we'll get the value of angle DOC as 55 degree. Next, we have to find out the value of angle DCO, this angle. So, in triangle DOC, we can clearly see that we know this angle value is 55 degree. The value of this angle is 70 degree. So, therefore, by angle sum property, we can take out the value of this one. So, the sum of angle DCO plus ODC plus DOC will be equals to 180. Sum of the three angles is 180. We will consequently put the values here. That will be equal to 180. Calculate the value and the final value will be 55 again. So, 180 minus 125 is coming out to be 55. Next, we have to find out the value of this particular angle OAB. Now, it is already given that ODC, this triangle is similar to OBA. Since these two are similar to each other, we can say that angle C right here, this angle DCO is equal to OAB, right? By this one, we know that the corresponding angles are equal. So here, if this is angle C of ODC, so angle C is equal to angle A of the other triangle. So angle C is equal to angle A. Okay. So these two angles are equal. Since we have already got that OCD or DOC, that is the same thing, that is equal to 55 degree. So therefore angle OAB right here will be equal to 55 as well. Hence we can write down the value of all the angles. Diagonals AC and BD of a trapezium ABCD with AB parallel to DC intersect each other at the point O. Using a similarity criterion for two triangles, show that OA by OC is equal to OB by OD. So here is the trapezium ABCD. Here it is given that AC and BD are intersecting at O, and AB right here, the side AB is parallel to DC. So since AB is parallel to DC, we can clearly say that AC is a transversal and also DB or BD is the transversal. Fine. Now from here what we can say, since AB is parallel to DC, we can say that DB is a transversal, and we can say from here that angle 1 right here is equal to angle 2, and again angle C right over here is equal to angle A, as AC is also a transversal because DC is parallel to AB. So angle 1 equals to angle 2 and angle 3 is equal to angle 4. So if we can prove that these two triangles, that is OCD and OAB or OBA, the same thing, if they are similar, then we can say that they will have corresponding sides, because OA by OC, so OA and OC, OD and OB, these are the sides of these two triangles, that is OAB and OCD. So we have to focus on these two. Since they are parallel, we can write down the conditions. So these are the things which have been already provided. We have to prove this. So for the proof, in triangle AOB and COD, we can see that angle 1 equals to 2 and 3 equals to 4 because they are alternate angles. So since we have two angles which are equal for two triangles, then we can say that by AA similarity criterion, triangle AOB is similar to COD. The triangle AOB is similar to COD. Again, the naming is very important. See, angle 1 is equal to angle 2, that is D will be equal to B. So D is equal to B. Angle 3 is equal to angle 4, that is angle C will be equal to angle A. Angle A will be equal to angle C. In the middle, these two are vertically opposite angle, right? Angle O for this angle triangle and angle O for this triangle are vertically opposite. We can also use it. So angle O is equal to angle O. So the naming is very vital. Now, since we have named it like so, as because they are similar by AAA similarity criterion or AA similarity criterion, therefore we can write down by corresponding sides of similar triangles. Since they are corresponding sides of similarity triangle, we can conclude that AO by CO, right? AO by CO is equals to OB by OD, OB by OD. We can just choose the name of the sides from here only. So, therefore, this is the thing they have asked us to prove, and we have. In question number 4, in the given figure, QR by QS is equals to QT by PR, and angle 1 is equal to angle 2. You have to show that triangle PQS is similar to triangle PTQR. So in the given figure we can see that angle 1 is equal to angle 2. So if we take triangle PQR, we can see in triangle PQR angle 1 equals to angle 2. So by theorem we know that if two angles are equal in a triangle, then its opposite sides are also equal. So for this triangle PQR, opposite to angle 1 is the side PR and opposite to angle 2 is the side PQ. So we can clearly say that since angle 1 equals to angle 2, therefore angle PQ will be equal to PR. Now this ratio is given QR by QS equals to QT by PR. So we can write over here that in triangle PQS and PQR, QR by QS equals to QT by PR. Now we have already proven that PR equals to PQ. So let's write PQ instead of PR. So the final ratio is QR by QS is equals to QT by PQ. So let's see this in the figure. So in the figure we have two triangles PQS and another PQR. With respect to the two triangles, we have the ratio QR by QS, that is QR by QS, and QT by PQ, QT by PQ. So we can see the corresponding sides are in ratio and the angle between them or the corresponding sides is angle 1. So PQ and QS, the angle between them is angle 1. For the other triangle, for the side TQ and RQ, the angle between them is also angle 1. So since both of them are angle 1, that is, the two sides are corresponding right here and the angle between them are equal. That is, angle PQS is equals to angle TQR, that is equal to 1. Hence we can say that by SAS congruence or similarity property, they are similar because side, angle and side. So SAS similarity criterion proves that triangle PQS is similar to triangle TQR. Again, we have to be very careful about the names. Since PQ is similar to TQ, so we'll write over here, and QS is equal to QR, so we have write it in the same. Question number 5. S and T are points on sides PR and PQ of triangle PQR such that angle P is equal to angle RTS. Show that triangle RPQ is similar to triangle RTS. Let's draw a diagram. So in this diagram we can see that we have two triangles or a triangle PQR and S and T are points on the side PR and QR. And if we join them, we will get ST. So again a new triangle STR is formed in PQR. The question is to prove that RPQ, this triangle, bigger triangle, is similar to RTS. Now it is given that angle P is equals to angle RTS. This angle P is equal to angle RTS right over here. So we can already see that these two angles are equal, which is already given, and for both the triangles angle R is common. Angle R lies in triangle SRT and also PRQ. So we are dealing with RPQ and RTS. In both the triangles we have angle R. So we have two angles which are equal and this angle is common, that is also equal. Therefore, since two angles are correspondingly equal to each other for the two triangles, therefore we can say by AA similarity criterion, triangle RPQ is similar to triangle RTS. Question number 6. In the given figure, if triangle ABE is congruent, this is the congruent sign, is congruent to triangle ACD, show that triangle ADE is similar to triangle ABC. This is the given figure. Here ABE is equal to ACD, right? So these two, this triangle and this triangle are congruent to each other. Congruent means corresponding sides are equal and corresponding angles are also equal. You have to show that ADE, this one, ADE is similar to ABC. So we can already say that in the triangle ABE and ACD, this angle is equal. So angle A is equal in both of them. Then by the name AB equals to AC. So AB will be equal to AC and BE is equals to CD. BE is equal to CD, right? AB equals to AC, BE equals to CD. This is what we are getting already from the triangle. We have to show that ADE, this one, is similar to ABC, the larger one. So since they are congruent, we have written AB equals to AC and AE equals to AD by CPCD. If we take their ratio, what we will get? AB by AE or AB by AC. So if we take the right hand side to the left hand side, we will get AB by AC, that will be equal to 1, and AE by AD, that will also be equal to 1. So we have written as such. And what else do we have? So the ratio right over here, AB by AC is equal to AD by AE. The ratios are equal. For the triangle ABC, we are taking AB and AC. And for the triangle ADE, we are taking AD and AE. So therefore they are equal, and the angle between them, DAE and BAC, are also common, that is equal. Therefore by SAS congruence or similarity criterion, ADE will be similar to triangle ABC. Question number 7. In the given figure, altitudes AD and CE of triangle ABC intersect each other at the point P. So here in this diagram we can see we have a triangle ABC, and in it we have AD as a perpendicular on BC and CE as a perpendicular on AB. So we know the perpendiculars always make 90 degree at the foot of the perpendicular. So angle E right over here and here on both sides it is 90 degree, and here also angle D on both sides will be 90 degree each. For the first question, we have to show that triangle AEP is similar to triangle CDP. In this triangle, we can see that AEP is this triangle and CDP is this triangle. CDP is this one, AEP is this one. So we can clearly see here that at point P, this angle is equal to this angle because they are vertically opposite angle. And here at angle E, it is 90 degree and angle D is also 90 degree as they are perpendiculars. So we can write over here that angle AEP is equals to CDP, that is 90 degree, and APE is equals to CDP, that is equals to vertically opposite angle. Since two angles are equal of the corresponding triangles, therefore we can say by AA similarity criterion, triangle AEP is similar to triangle CDP. In the second part, we have to prove that triangle ABD is similar to triangle CBE. So here, the triangle ABD is this one and CBE is this one, CBE. So this is CBE and this is ADP. So for both of them, we can see that angle B is common to both of the triangles. So this is one angle which is common, that is equal. And again, for the perpendicular CE in this triangle, we can see E is 90 degree, and for triangle ADB, angle D is 90 degree. So we can clearly see two angles are equal. So we'll write so angle ADB is equals to CEB because they are 90 degree, and angle ABD is equals to CBE because they are common. Therefore, by AA similarity criterion, triangle ABD is similar to triangle CBE. In the third case, triangle AEP is similar to triangle ADB. So, AEP is this particular triangle and triangle ADB is this one, ADB. So, this full triangle is ADB and this small one is APE. So, we have to prove they are similar. To prove they are similar, we can see that in both the triangles we have angle A as a common angle, and here angle E is 90 and angle D is again 90 over here. So we can say that angle AEP is equals to angle ADB because they are 90 and angle A is common. Therefore, by A similarity criterion, triangle AEP is similar to triangle ADB. The last part is including triangle PDC and BEC. So PDC is this small triangle and BEC is this big triangle. So in PDC and BEC we can see that angle C is common to both the triangles, and again angle D is 90 degree here and angle E is 90 degree. So we can say that angle PDC equals to angle BEC because they are 90 and angle PCD is equals to angle BCE because they are common. Therefore, by AA similarity criterion, triangle PDC is similar to triangle BEC. In question number 8, E is a point on the side AD produced of a parallelogram ABCD and BE intersects CD at point F. Show that triangle ABE is similar to triangle CFB. In the diagram, we can see that we have a triangle parallelogram A, B, C and D. So we know that ABCD is a parallelogram. So a parallelogram has the properties where its opposite angles are equal and opposite sides are also equal and parallel. So we will draw the diagram, and it is said that E is a point on the side AD produced on a parallelogram ABCD. So if you take the side AD and produce it, we will get the point E. So that BE will intersect the line CD at F. So E is on the produced line of AD and BE will intersect the line CD at F. Now, since ABCD is a parallelogram, we can clearly say that angle A is equal to angle C because they are opposite angles of a parallelogram. And again, we know that AB is parallel to CD because it is a parallelogram, opposite sides are parallel to each other, and we can consider BE as a transversal. If BE is a transversal, then we can say that angle ABE right over here is alternate to this angle. These two angles are alternate to each other because BE or FB is a transversal for the parallels CD and AB. So let's write it over here. In a parallelogram ABCD, angle A is equals to angle C because they are opposite. And in triangle ABE and triangle CFB, the same thing can be written, right? In ABE triangle, this is ABE or EBA, EAB, and this is BCF. So these two are equal in these two triangles, and again we can say that angle ABE, this angle is equal to BFC, this angle, because they are alternate, as BC is parallel to AB. So we have got two angles, corresponding angles which are equal. Therefore, by AA similarity criterion, we can say that triangle ABE is similar to CFB. So AB right over here is equal to CF because opposite to angle B right over here is AE, and opposite to angle F here is BC. So BE will be equals to BC. So here we have the. Hope you have understood. Thank you everyone for watching.